Hey guys, today is Thursday, May 28th. We are continuing with the triangles unit, and today we're talking about something called the exterior angle theorem. So when you hear the word exterior, think of it like being outside of the triangle. And the exterior angle of a triangle is formed when we extend any side of the triangle. So for the first one here, and you don't have to put these into Microsoft Forms, this is just to see where the exterior angle is. The exterior angle would be this one, and it's called angle ACD. That one's written in down here. So for the next one, the exterior angle would be right here, outside the triangle. Notice we extended one side of the triangle, and that would be angle DGS. If we were naming it, you could also call it angle SGD if you were reading it the other way, as long as the G is the middle letter. And for the last one, the exterior angle is right here outside of the triangle. That would be angle ACD. You could also call it angle DCA. Now we're going to get into the exterior angle theorem, and before we start using the theorem, two things to remember. First, remember that the sum of the measures of the angles inside a triangle is 180 degrees. You guys did a fantastic job with that yesterday. Second, remember that a straight line, a straight angle, has a measure of 180 degrees. And we're going to use that for number one here. So it says, determine the measure of the missing angle in the triangle. So basically, we want to find this angle right here. I'm going to mark it off with the red arc. And this we're using the same theorem that we have for the past few days. We know the two angles that are given, so we're going to add 63 plus 86, and that would equal 149 degrees. So to find the missing angle, we have to subtract that from 180, so 180 minus 149 would give us an angle that is 31 degrees. So there's our missing angle measure. I'm just going to draw an arrow in because I don't quite have enough room, and I apologize for the screen sliding. So this angle is 31 degrees. Now we have to find the measure of the angle marked as X, and this is where that straight angle is going to come in because I want to mark it off with those two angles. So notice the angle we just found, which is 31 degrees, and that angle marked as X form a straight line. That means they're supplementary. They add to 180 degrees. So then I could just say, okay, to find that angle marked as X, I've got to subtract 180 degrees minus the 31 degree angle that we just found, and that equals 149 degrees. So in this case, X equals 149 degrees. And before we move on to number two, I want you to notice something kind of interesting that's going to become exactly what we're using today. Notice we got 149 degrees as the measure of angle X, and when we added together those two angles at the very start of number one, they added to 149 degrees. That's something that we're going to be talking about with the GeoGebra app that you see down below. Okay, this GeoGebra app is coming from the link right here where it says exterior angle theorem, triangles, and the question is, based on the animation, what do you think is the relationship between the exterior angle of the triangle and the green and pink angle together? So I'm going to open it up, and this one is pretty simple. You can change the size of the triangle, and it'll change the pink angle and the green angle, but all we're using is this one slider. So when I slide the pink angle and the green angle, notice they come together and they fill in that exterior angle. I'm going to reset it. I'll change the size up a little bit. And let's see. Pink angle and green angle fill up the exterior angle. So coming back to OneNote, remember when we looked at those two angles from the example up above, where it was 63 degrees and 86 degrees, They added to 149 degrees, and we found that the exterior angle was also 149 degrees. So I would say the pink angle and the green angle combine to fill the exterior angle. That's what we could tell for right now. Now let's get into what the exterior angle theorem actually means and how we can use it to answer these questions. So to use the exterior angle theorem, the important thing is that the measure of the exterior angle is equal to the sum of the two remote interior angles. And remote interior angles mean that they're the angles that do not touch the exterior angle. So coming back up to the model we used here, the remote interior angles were 63 and 86. And notice when we added those angles together, it wound up equaling the exterior angle. We just solved it a little bit longer in number 1 to show you this is where it comes from, but now we can use the exterior angle theorem shortcut. Alrighty, we are just going to knock out 3 and 4 as the examples here. The rest of them are for you guys to finish. So looking at number 3, we're trying to find the exterior angle right here. And we have the two remote interior angles. I'm going to mark them off in blue. Remember, remote interior angles means they are not touching the exterior angle. So all we have to do to find the measure of angle x is add those remote interior angles. 30 degrees plus 14 degrees, and that equals 44 degrees. So for this one, x is equal to 44 degrees. For number 4, this one's a little bit different. Sorry for that thing popping out on the side. Now we are given the exterior angle, and we have one of the remote interior angles. We're trying to find this measure for angle x. So remember, we could add the remote interior angles to equal that exterior angle. Since we're working backwards here, we'd have to say, okay, we know the exterior angle is 117. So I'm going to subtract 117 minus the angle we have, which is 43, and that will tell us the other remote interior angle. And you should find that the measure of this angle is 74 degrees. So in this case, x equals 74 degrees. And just to prove it, if you did a check and you added the remote interior angles, so 74 plus 43, you would see that it comes to equal 117, which is the measure of the exterior angle here.